Hello everyone. In the process industries, there are different types of process fluid available with different properties. Hence, different types of meters are available. Vortex flow meter are one of the most useful flow meter used in process industry. Here in this video we will learn about working principle of vortex flow meter, its application, advantage and disadvantage, parts, construction, mounting, material selection, sizing of vortex flow meter, technical data sheet preparation, technical bid analysis document preparation, installation of vortex flow meter, outline dimensional drawing and reputed supplier. Working principle of vortex flow meter. Vortex flow meter have three parts. It's meter body, sensor and transmitter. An obstruction on the flow path called as shader bar or bluff body causes for the alternating vortices due to differential pressure across the shader bar. These vortices caused by small sensing element either behind or within shader bar to oscillate at specific frequency. Velocity of fluid is directly proportional to vortex frequency. This phenomenon is called as Karman effect. By knowing cross-sectional area of the pipe, volumetric flow can be calculated. Proportional constant can be found in the lab by using pulse generator to the volumetric flow, which is noted by K factor. To measure accurate flow, an adequate ratio of inertial force to the viscous force must be exist. If not, then meter will show no flow when fluid is flowing. Once a mechanical signal has been formed by vortices passing by the shader bar, a piezoelectric sensing element takes mechanical signal and convert into the electrical signal. And this electrical signal pass to electronic board and process it to turn down into the velocity and flow reading. This signal again transfer to the local display or control system. So we can calculate the volumetric flow Q, which is directly proportional to the frequency, where the formula is Q is equal to F into D upon K, where F is the vortex frequency and D is the inner diameter of the pipe. K is the K factor, which is ratio of pulse transmitted to the unit volume, and a frequency can be calculated by St into V upon C into D, where St is the Stall number dimensionless, V is the fluid velocity at the shader bar, and C is the constant ratio small d by capital D. Application of vortex flow meter. For a variety of applications and industry, it's work very best for the clean service, low viscosity, medium to high speed of fluids. It can be used for custody transfer of neutral gas and metering skid also. Steam measurement, fluid for liquid suspensions, general water applications, liquid and chemicals and pharmaceutical applications. So in short, superheated steam and liquid at its saturation point can be measured by the vortex flow meter. It is very important flow meter and its accuracy is also better than the DP type of flow meter, and its pressure loss is also less than the DP type flow meter. Hence, it can be used with respect to the accuracy and pressure loss. Advantage of vortex flow meter. Vortex flow meter can be used for liquid and gas and steam applications, relatively low cost for installation and maintenance, low wear impact, low sensitivity to variation of process conditions like pressure and temperature conditions or density variations, stable long-term accuracy and repeatability, low pressure loss, applicable to wide range of process temperature, available for wide variety of pipe sizes. Disadvantage: it is not suitable for very low flow rate. However, for few low flow rates we can use reducer types of vortex flow meter, where it can reduce its sensing area, so velocity at that point can be increases and we can calculate the accurate flow at low flow also. It is not suitable for pulsating flow. In short, below is the specification of vortex flow meter. Its inaccuracy is 0.5 to 1% of rate of liquid, 1 to 1.5% of rate of gases and steam. The standard sizes available in the market is 0.5 inch to 14 inch, and design pressure is 2000 psig or 138 bar. Design temperature is available up to -330 to 750 degree Fahrenheit. Minimum Reynolds number is required 5000. Parts, construction and mounting. So here is the picture about parts. So mainly there is three part: meter body, sensor part and transmitter. In meter body there will be a tube in which there will be a shader bar, and at the both end there will be end connection. Either it will be flanged, either it will be butt weld connection, or it will be threaded connection. Second part is sensor part. It is the piezoelectric sensor which convert the mechanical signal to the electrical signal, and then electronic transmitter which is used for showing flow on the local display or transferring the signal to the control system. Its construction available with various types of flow meter like wafer design, flange design, insertion design, welded design and threaded design. The most commonly used is flange design. However, in some applications we can use the welded design also, like in very low temperature in LNG applications. Mounting is available for remote and integral for vortex flow meter. As per the temperature and suitability of access, we can use either remote or integral mounting. In integral mounting, transmitter and sensor will be together. However, in remote mounting, transmitter will be mounted separately with 2-inch pipe mount, and there will be interconnecting cable within transmitter and sensor will be required, which is provided by the supplier only. This flow meter is available in various types of ratings like 100, 300, 600, 900 and so on. Material selection. Basically, the weighted part have different types of material available for the vortex flow meter. In the market, SS316, nickel alloy, carbon steel, tantalum, dual certified, these types of material are available in the market. Transmitter housing is available in two different material: aluminum housing and stainless steel housing. Whenever we will do the material selection, then don't forget for PT rating checking, because pipe material can be different and flow meter body material can be different. Hence, different types of rating can be found. So whenever we will do the material selection and we will prepare the technical data sheets, we need to do the PT rating checking as per the ASME standards. Here is a short description about PT rating checking. You can use for your reference. So for PT rating checking, there are different grade of material available. So for carbon steel grade, it is GR 1.1. For stainless steel, GR 2.2. For SS316L stainless steel, it is 2.3. Duplex, it is 2.8. For monal it is 3.4 and hastelloid is 3.8. So these are the grade of the material, and there are different class available, and for each class all the grades have different types of temperature suitabilities there. So here is the temperature suitability, and this area is for the pressure suitability. So you can check for a specific class. For carbon steel material and stainless steel material have different types of pressure rating. So whenever we will make the technical data sheets, we need to check what is the temperature and what is the pressure available which is received from the process department. So at that particular pressure and temperature, what is the rating for carbon steel material and what is the rating for stainless steel material. So in that case we can select the proper rating. Meter sizing and vendor calculation review for Vortex flow meter. Whenever we will do the meter sizing, then first of all we need to check the process data very carefully, and during the sizing we have to know that we cannot size meter over than line size. That means either our meter size will be equal to the line size or it can be smaller than the line size. Let's do the sizing of vortex flow meter by our tools that is known as Instrumentation. Here you can see there is the data available in yellow. So we need to provide some input data like tag number FT-1001 and maybe any fluid XYZ. So this maximum gas flow, flow temperature, minimum meter inlet pressure, molecular weight, specific gravity, viscosity, density, these value we can put from the process data sheet which is provided by process department, and we have to do the meter sizing by either auto selection or manual selections. So whenever we will select this auto, then the sizing will be done by the software only, and we can do at different sizes for accuracy and pressure loss value. So let's do the sizing. So suppose this value we have taken from the process data and we are doing the auto sizing. So whenever you will do the auto sizing and you will put on the calculation, then some value will be available as output, and automatically it will select the meter size. So what is the meter size? It is 40 mm or 1.5 inch meter size. But we need to check whether this meter size is suitable for us or not, because first of all we need to check whether what is the pressure loss with this 1.5 inch meter size. So if you will see the output, then the pressure loss is 12,435 mm H2O. There will be a allowable pressure drop value provided by the process departments. So if this value is less than the allowable pressure loss, then that means our pressure loss calculator is okay. Otherwise we have to reduce the calculated pressure loss. In the same time we need to check the accuracy also. What is the accuracy are available? If we will not get the proper accuracy, then we have to go for the further meter sizes, like we can go either down size or up size. So this is the auto selection, and whenever you will do the manual selection, then you can go with different sizes. Like suppose our calculated pressure drop which is more than 12,000 mm H2O, it is greater than the allowable pressure drop. Then what we can do? We have to reduce this calculated pressure drop. This can be reduced by increasing the meter size. So suppose we are selecting the 50 mm meter size and we are calculating. In that case, you can see the maximum pressure losses decreases. Now, if it is below than our allowable pressure loss, then it is okay. And also we have to check the minimum flow and maximum flow which is suitable for our meter size or not. That means our minimum required measurable minimum flow and maximum flow shall be within this range, and this is the rangeability of meter. So these output we will take and we will put into our technical data sheets. So this way we can prepare the technical data sheet, but sometimes we not need to do the sizing at our end because vendor already provide the sizing calculation. So let us see some sizing calculations from vendor. So this is the one of the reputed supplier. It is called Rosemount or Emerson. So they can submit you these types of sizing calculation for Vortex flow meter. Whenever you will review the sizing of Vortex flow meter from Rosemount or any vendor, first of all we need to check the process data properly. Like what is the line size vendor have taken, what is the operating condition of pressure and temperature, what is the density, phase density, compressibility, operating viscosity, vapor pressure, etc. All this data based on the process data sheet we need to verify first of all. Also flow rate at minimum, normal and maximum condition that is captured here, that we need to verify. So basically Emerson do the size for different sizes and they can select according to their standard of selected meter size. Just like for this FIT 10001 tag, Emerson provided 6 different sizing calculation and they have selected 150 mm with reducer vortex meter. Means its a flange will be 6 inches to match the pipe size, but it's a shader bar area or it's a sensor area will be reduced by 4 inch. So they have selected this yellow shaded sizing, but they have provided the different sizing. So now we will review this sizing, and what we will see in this sizing, we will check the meter size first of all. We will see the pressure drop at maximum flow for different sizes and accuracy at maximum flow and minimum flow. Also we will check the minimum cutoff flow. Minimum cutoff flow is the value below meter will not show the flow rate. Hence our process data minimum flow must be greater than minimum cutoff flow. So here they are mentioning the default low flow cutoff. I can show you here they are mentioning default low flow cutoff. This is the value for different sizes. So first of all we need to check our required minimum flow shall be greater than this default low flow cutoff. If suppose the 150 meter size have default flow cutoff is 4373 and our requirement is 4000, that means this 6 inch is not suitable, then we have to go further 4 inch with reducer where we can get the minimum default flow cutoff at 1126 and our required 4000 is greater than the default low flow cutoff, hence it is measurable. So this way we have to check the default low flow cutoff for each sizes with respect to our required minimum flow. Then we have to check the pressure loss at maximum flow. Pressure loss at maximum flow will be different for different sizes. As per process, allowable pressure drop shall be greater than calculated pressure drop. So we need to check which meter size is suitable. At the same time, we need to check the accuracy also. What is the accuracy available for minimum and maximum flow? So these 3-4 conditions simultaneously we will check for each sizes, and we will find the best suitable meter for particular process condition. Here is the accuracy chart, and similarly there are different pressure loss and accuracy for different flow conditions. So you can see below 1680 it is 100% inaccurate, and above this you will find the inaccuracy of 1.35%. However, the pressure loss will be 0.10 kPa. So this way we can check our minimum flow and maximum flow, so we can get the pressure loss at maximum flow and pressure loss at minimum flow, accuracy at maximum flow and accuracy at minimum flow. So by this value, by this chart, we can get the pressure loss and accuracy at minimum flow and maximum flow. Also we can find here the default low flow cutoff, which should not be greater than our minimum required measurable flow. So this way we can review the sizing calculation from vendor, and we can prepare the technical data sheets. Preparation of technical data sheet. For Vortex flow meter, whenever you will prepare the technical data sheet, then you have to follow some certain process. First of all, you have to review the PNID, then you can get some general information. Then you will use the PDS for process conditions. Also you will use the PMS for pipe schedule, pipe material, pipe thickness, etc. details you can find from PMS. Again, you can use the client flow meter specification for certain requirement from client. Then you can use a certain format for datasheet preparation of flow meter, and you can start making the data sheets. So here is the one sample data sheets you are seeing, and here is some data sheets fields are available that you can provide it in your technical details. So general informations, where we will provide the general information like tag number, quantity, line number, material, size, schedule, class, rating, area classification. These details we can provide in general informations. So I can show you one reference data sheets. So here is the general information. You can provide this information from PIN-ID, and this service conditions also you can provide, you can receive from process department, and there is a document which is called PDS. So you can find this information from PDS, and you can enter into your technical data sheets. Again, the element or sensor, then you have to provide the information for sensor or element. Basically this will be unique for each flow meter, and rest of the maximum things will be like same. So we need to discuss this specifically. Like meter type is Vortex flow meter, body size is 2 inch. So we can match the body size to the line size, and if you want to reduce the body size based on the sizing calculations and client is accepted this reduced body, then we can use the particular calculated size. And meter style, either it can be flanged, it can be welded, it can be insertion type, or it can be threaded, or it can be reducer type also. So different meter style are available for different supplier. We can use the best suitable or required meter style. Sensor type and material. Basically there will be some specific sensor like piezoelectric sensor which used to convert mechanical signal to the electrical signal. So that is the standard by the manufacturer, they can provide accordingly. So we can put this detail from the vendor information. Again, end connection type and finish. So end connection will be depend on the meter style. So if you are using the flanged connection, then you can mention here the flanged raised face and the finishing is 125 to 250 micro inches, and connection size is 2 inches, which is same as body size, and rating will be according to the piping and according to the PT rating, and connection material will be either stainless steel or equal to the piping. Again, body material and shutter bar material, different materials are available. So based on the process condition, like whether it is corrosive or not, so we can select the proper material, but most commonly used the stainless steel or duplex types of material in the market. Mounting plane is horizontal. So Vortex flow meter can be installed horizontal or vertical also. So based on the 3D model or plant requirement, you can use the mounting plane. Minimum straight length required. This is very important point. Basically, for different supplier, minimum straight length is different. However, we can provide the minimum information. Minimum requirement is 10D, 5D, but we will see how the different straight run is required for different conditions. Fluid velocity at maximum condition, meter accuracy at maximum flow, meter accuracy at minimum flow, default low flow cutoff. This information we can find out from the vendor calculations. So as recently we have seen the sizing, so we can find these information and we can put here. Face to face dia will be available only when the vendor will submit outline dimensional drawing. So this sensor details is unique, so we need to provide it. And then head connection is same like different types of meters. So if it is remote mounted, then there will be a separate head for the sensor, and another transmitter will be there. And if it is direct or integral mounted, then there will no any head connection separately will be there. So in that case you will keep it as blank, otherwise you need to provide this information. Transmitter is same as the conventional transmitter, like it is the 2-wire loop power 24 volt DC powered transmitter, which can provide 4 to 20 milliampere output. Its housing you can select based on the requirement. SS housing and aluminum housing is also available. So based on the project requirement, we can choose the housing. Enclosure class is also available, explosion proof and intrinsically safe. As per the project requirement, we can select. Weatherproof class is IP66, IP67, 65, different available. We can select as per our requirement. So these are the details of the transmitter which is common. So we can put over here and we can make the datasheet complete. Again, if any accessories like gasket, cable gland, or cables from sensor to transmitter, so these types of accessories details we can mention here. Some optional requirement is there, then we can put here, like is there any flow computer required or any custody transfer application is there, cable related data, any compliance standard which is mandatory for this flow meter. So these types of details we can put over there. Meter range and calibration details also we can provide based on the minimum and maximum flow. So how we will find the calibration range? So first of all, we need to take the 10% extra to the maximum flow. Suppose our maximum flow is 100 nm cube per hour. Then we will take the 10% extra, like 110 nm cube per hour, and we will calibrate this maximum extended flow from the zero. So our total calibration range will be 0 to 110 nm cube per hour. So this way we can find out the calibration range. For each meter of Vortex, we can find the calibration range by adding 10% to 15% on the maximum flow, and we can calibrate it from 0 to that maximum limit. This purchase data is also available here, so we can find this information from vendor input and from different document, so we can put these informations later on. And this is the title block. We will update time to time accordingly, and the note information will be mentioned here. So this is the data sheet we need to prepare for the Vortex flow meter technical bid analysis. Once our technical data sheet will be ready, we will send it to the bidders for the inquiry. So they will submit the inquiry. Then we will review it and we will prepare the technical query. We will take the response from the vendor. We will try to make all the bidders in line with our requirement. After that, we will prepare this technical bid analysis document. This is very important document for the selection of vendor. So in different flow meter also we have discussed about this document, like how we can prepare it. So basically there is a description which is the details we required for, and here is the project requirement we will mention with respect to our description, and all the other three vendors technical quotations will be in line with our requirement. So what they are provided, we can put their information and we can compare. So this is the comparison within the all bidders with specific project requirement. So these are the technical details and these are our project requirement, and these are the tag wise details. So one by one we will put different tag, and we can prepare this tag wise details, and whatever the informations available from different bidders, we can put that information here, and that we can compare which vendor is more technically suitable. So we can put them at different level, and accordingly all the three vendors will be at different level. So based on this technical bid analysis, we can do the commercial bid, and according to the technical and commercial bid, we can select the vendor or supplier for the particular commodity. So this is the technical bid analysis document you need to prepare in each and every engineering project. So installation is very important for vortex flow meter because upstream and downstream straight length is required. If upstream and downstream straight length will not be available, then accuracy will be affected because its vortices will be affected. As we know that at the downstream, just to the bluff body or shader bar, vortices are generated. So whenever the sufficient upstream will be not there, then the frequency of the oscillation of vortices will be affected, causes the accuracy effects. So here is some different criteria for reducer pipe, for extended pipe, for two elbow, so, and for regulating valves. Different types of conditions, different types of straight length is required. But this is the general information. Whenever we will go with specific vendor, then they have specific status requirement, so that we will update later on in our drawing and document, and we will prepare the installation details accordingly. Outline dimensional drawing. This outline dimensional drawing will be submitted by supplier, and it is the tag wise drawing because different sizes of meter have different values. So it is the dimensional drawing. It is very important for the checking of 3D model or making the installation details for clashing checking in the model, and also for the accessibility point of view, this dimensional drawing is very much important. So vendor will submit with model number, tag number, rating, material. This dimensional drawing will be submitted to the engineering department. So as a engineering department, we will review this and we will approve this. Then after, only this flow meter will go in the manufacturing. Until we will not approve this general arrangement drawing, manufacturer will not start manufacturing. So for our accessibility point of view and 3D model point of view, the general arrangement drawing is most important. Also, mechanical department will use this drawing for making their isometrics. So we will share this drawing to the mechanical department or piping department also. They will review and they will comment if any. So we can incorporate that comment also, including our comments. In the same drawing, there will be some other drawings will be there for terminals details. So you can see there will be integral and remote different types of terminal details according to the tag number, and we will use this termination details in our loop drawing and wiring module. So whenever we will do the wiring and loop drawing either in software or in manual, so we will use this termination details and we can do the wiring and we can prepare the loop drawing. So this data is very much important for further engineering purpose also, and also for the different documentation purpose. So these details we will find from vendor. Once we will approve, then only manufacturing will start. Reputed supplier. So some of the reputed supplier are Rosemount, Anderson Hauser, Yokogawa, ABB, Crone Marshall, Siemens. These are the reputed suppliers who providing the best vortex flow meter in the world, and you can choose accordingly. Thank you so much.